Today we have Kyle Lowe as our guest from the Allen Institute for Artificial Intelligence. Welcome to the podcast, Kyle.
Hello. Hi. Nice to see you, everyone.
So today I would like to talk with you, Kyle, about science of science, which is something that you have been working on for a long time. Pradeep and I did some work on it as well. So I would love to kind of like pick your latest thoughts on this. You've been leading a lot of the research that's happening in Cement Scholar in this area, and I think a lot of people can benefit from your understanding of it. So let's start with, what is science of science?
Yeah. Well, I'm gonna disclaimer that I'm like science of science. That I specialize in very particular aspects of science of science. So it's a very broad area. But I guess my understanding of it is it's basically a field of computational sociology. The goal is to use computational methods or large-scale methods to study the process of science. And so this might be studying how the communities, scientific communities, how they share ideas, communicate, publish, write, build off each other. It might be studying the individual scientists within a particular community, how they form ideas, how they approach problems, etc. It might be studying sort of like technology that's available, not available, studying how funding influences science. Is kind of everything to do with how science is conducted and progresses. Any studying that meta question of science through scientific means is science of science.
That sounds very broad. So
it's super broad, yeah.
There's no one. Would you say there's a coherent community who does CSR, or is it really comprised of multiple sub-communities that don't talk to each other?
I don't know how. I would say at the very least, I think it's super broad. I think like there's a lot of communities that conduct science of science on their own community, because it's sort of like, for me, I'm an NLP person and I'm interested in how NLP research is being done by its community. So I'll maybe have connections and collaborations with other people who study the NLP community, but not as much connection with like other groups that are happening within chemistry, within other subfields of biology, et cetera. So there's probably a lot of diffuse science of science work within that's community specific. And then there's sort of like people who do like more overarching work, James Evans, Carl Bergstrom, who do like kind of all of science across multiple fields, how when they study like information flowing from like chemistry to biology, and then biology to computer science, et cetera. And those also have diffuse, sort of diffuse publishing communities as well. So I think people kind of know each other, but like having a really good handle of who's in this space is a little bit tough.
How old would you say this community is? At least the way you've defined it, it seems like it's something that people have been studying for a while.
Oh, I guess like forever. So like I think like as long as science is like sort of scientific method, scientific studying has existed, people have sort of studied this meta problem. Like, what are we doing actually? Like, what's the right way to be doing this actually? Like, I think like there's one I would consider science of science paper that is often cited. It's like by Kuhn, like I think it's like in the 60s even, studying like this idea around like paradigm shifts in science and stuff like. So like even back then, people were studying just like, what does it mean to do science and how does science progress? At that time, they were thinking about like more philosophically, just like, oh well, when do people adopt new ideas? When do scientists get pushed to develop new techniques, or do they exploit sort of existing practice and really go and really refine existing ideas? And so like, I don't know, 60s, even predating that, probably even in the 30s, people were doing this and before.
Cool. Yeah. What about this field is really exciting to you? Why did you get into it?
I think for me, so ultimately my focus is I want to build useful tools that helps scientists do work. And really what that means is you need to have some sense of like what is useful, and not what is useful for an individual scientist, like building something that an individual scientist would be happy to use, but also what is good for a field. So what is good for a particular publishing community, and without studying science of science, I don't really know what it is that we should be aiming for. Like, what is a healthy state of a community that is progressing in science versus potentially without thinking about science of science, you might end up building tools that just every individual scientist is using, but doesn't benefit the field as a whole. It just stresses everyone else out because they have to adopt another tool. So science of science is more of like gives me like a sense of like, oh, this is a good direction, this is a bad direction.
I guess you've been working on that for 7 years, 6 years
Oh
now.
dear, yeah.
You're old, Kyle.
I know.
How did you start hearing about this mission of like enabling scientists after you joined AI2 and Smash Solar, or did you feel like this was something that you cared about even before joining?
I think even before joining, I cared about this. So like, I guess back in school when I was still doing old classical statistics, I was mostly focusing a lot on like social network analysis, computational social science, like statistics for social science. And so one of the interesting data sources to study there is basically like academic graphs, citation networks, and like transmission of information. So I guess that was always a part of it. But it definitely accelerated a lot more after joining this team.
No wonder you were a top candidate.
Oh my God.
Okay, so one of the typical, like the prototypical examples of work that really made a big impact in this area is a paper published a few years ago in Nature, 2019. Lingfei Wu, Dashun Wang, and James Evans. The title of the paper is "Large Teams Develop and Small Teams Disrupt Science and Technology." We actually hosted that in the podcast, like when it came out, and I know that Kyle knows about this work, so I'm, bringing it up. And to me, it kind of like it captures the essence, but I imagine it's only one sub community that like tries to understand this. But it really gives me like the like a clear blueprint for if you want to create a big shift in how people do science of science, you want to kind of like analyze data at a large scale and come up with a nugget of understanding that people did not have in this coherent way before. And honestly, whenever somebody comes up with a conclusion like this, a lot of people will post-rationalize and say, yeah, we already knew that. But the fact that you have data to back it up and clear examples and publish in a top-tier journal, it does make a difference.
Yeah, I think so. I guess, sorry, what's the question?
That wasn't a question.
Like, I mean, yeah, I think it's great work. It's it's a flavor of work that I guess what it does is it provides theory that feels testable. It's not easy to test, but it feels testable, and that's kind of the flavor of science work that I do like. It's like if it like under that paper, after reading the paper, you as like an NSF grant person who decides what to fund, or you as like a university administrator deciding how to manage large pools of money to fund different types of academic departments. You might read that and go like, oh, maybe I want to move things around a little bit to promote these types of smaller groups. And that's a testable scenario then. It's very hard because you can't really have like a world in which you did a thing and a world in which you didn't. So there's like difficult statistics you have to do, but at least it feels like after reading that paper, you have some ideas on how to make better decisions. So I quite like that flavor of work.
Awesome. So the next question we had is, what are the key goals of SciSci in your opinion? SciSci is what we're using to like as a shorthand for science.
Sounds good. Sci squared. Sci. The key goals, I guess. So for me, science of science ultimately is to help us as sort of like researchers, scientists, basically stakeholders in the activity of science, to just have a better understanding around what's going on. It's like physics for me. It's like just like understanding how things move, how things play. It's like it's like economics or physics or just like any sort of like large phenomena understanding type of need. If I understand the process of science, how ideas are transmitted, how good ideas are formed, how scientists adopt information. This influences me individually as a researcher, how to act better. So I can get form better opinions about what I think is a better way to present my work. So I can write better potentially, or I can have a better way of designing my experiments, or even have a better sense around what problems to pick on, to work on versus what problems to avoid. Like, for example, Science of Science might guide my opinion around what I consider to be an impactful contribution or a long-lived contribution if I understand more of that theory, and then that influences my day-to-day decision-making. As a developer of systems that try to help systems or tools, or I guess like models that can be used to help scientists, this Science of Science also helps inform what I should build. Make sure I'm building that in a way that is good for a community of scientists, but also has the right incentives because we understand how individual scientists think, et cetera, et cetera. So just like make sure that I'm not wasting my time building something that is like completely off the mark. I guess ultimately that's me. It's like understanding. It's for improving human understanding so that we can make better decisions, either at an individual level or maybe at a community level, as well as like specifically for tool building. It's like knowing what to build and how to build it.
How much of this do you think is field specific? You did mention earlier that within different fields, people do study their own fields, right?
Yeah.
Do you think the goals are also somewhat field specific?
I think so. I actually suspect a lot of Science of Science is happening in a field specific manner. There's definitely like these like really seminal works that show up in like Nature, PNAS, Science, etc. These like venues that sort of like are like broader. And I guess like with any science, there's like stuff that's a little bit further out, that's more general and maybe takes a bit of time for people to absorb and understand how to apply it directly to their communities. Whereas community specific work is a little bit shorter term in terms of like its benefits, like it's a lot more actionable. So like an example is like of like a community specific study is we had a project with Lucy Wang at UW and an intern Hancheng Kao at Stanford around looking at hyperlinks in archive preprints and how like there's been an increase in usage of hyperlinks in these papers because archive deals with physics, computer science, math, statistics, and as computational methods are increasingly used, there's a lot more links to these like data artifacts, links to sort of videos, other artifacts that aren't necessarily contained in the paper itself. And so you can think of like the scientific work itself is more diffuse onto other non-paper artifacts, non-archival artifacts that are on the internet. And what happens is you try to go get the data set, you try to go get the code, et cetera, and it's gone. Because it's not archived in a stable manner like a paper is. And so what we were studying is like, oh, well, are people actually increasingly using hyperlinks to basically share scientific artifacts? And simultaneously, how preserved are those artifacts? Like if you just try to revisit hyperlinks from like a year ago, how often are they just gone? And this type of study really makes sense when you're talking about communities that use a lot of hyperlinks to share artifacts. In another community where this is not as the case, like maybe if you're more like a theoretical field, this study doesn't really quite make sense. So, or it's not as applicable. So this is kind of what I mean by like there's like smaller scale scope studies that feel a lot closer, which is why I don't know a lot about what's happening in a lot of other fields.
You know what? That reminds me of this paper. It's not even a good paper, but like I put it out a few years ago, and I keep getting people asking me to help them use the link to a GitHub repository that I linked there. And it's like, yeah, I'm not working on this for many years now. Sorry guys, and I'm not going to like spend a lot of time on this. And but it's to your point, it's slightly better than having the link, having a broken link, but still it speaks to the same thing where people put in a link that is not necessarily sustainable or not necessarily maintainable on the long term. I wanted to ask you, I thought what you would say as like a key goal for SciSci, given that you work for Science Scholar, is accelerating science, because my knowledge about the team is like this is the mission, and accelerating science So I'm going to do a straw man argument right now and like
Sure.
attack this, even though you didn't say it.
Sure.
Because it's something that I really genuinely want to discuss with you in a thoughtful manner, given that you have been like a big part of that group for a while. How do you think about accelerating science, and do you consider that to be a goal? Maybe not your goal, but is it a goal inside?
I think it's definitely in science of science. I think to an extent, yes. I think if I think about like science of science as helping improve human understanding around the process of science, and understanding is meaningful if it guides your decision making. For these kind of like at the end of the day, what types of decisions are we trying to make? We're trying to make better decisions that promote science. All of these that reduce barriers for scientists so that they can focus on the impactful work, et cetera, et cetera. All of this is in service of some sort of accelerant. I think people might disagree on like what direction they're accelerating to, but any sort of understanding to make better decisions is essentially an optimization procedure, and optimization is always in service of accelerating towards some direction. Now, what direction that is, what that means, like what is that world state, I think people might disagree.
So like one thing that I'm very passionate about is reducing income inequality, which kind of like in this realm, it translates to leveling the playing field so that not all the work comes out of the, like the Western countries, the more advanced, wealthier, governments and, research groups. My mission, like part of my mission at HIGG is to actually basically diffuse this or like really help people who currently have like one hand tied behind their back to be able to advance the science they're doing, the research they're working on to some extent as fast as other people like, for example, Stanford or CMU. Of course, I have nothing, like I benefit a lot from we're going to CMU myself, so I cannot complain about that, but I would love to have a broader footprint, right? Like I would like everyone to be able to contribute to this. And the key aspect, which I only realized a few months ago, is this concentration of work and acceleration of work happening by those groups reflects on what kind of problems we are working on. Because when you face certain problems as a researcher, you find yourself more preoccupied with them, and you put your energy and effort and funding towards that goal. So if the people who are doing 90% of the work, or at least of the prestigious work, happen to be in wealthier countries and in wealthier research groups, they will fundamentally be working on the rich people problems.
Yeah, I think I broadly can see that being the case. I guess like science of science. So let's take the specific goal of just like what you're describing is leveling out the playing field, making sure everyone who participates in the activity of science has like an equal, fair shot at being involved. Involving more people, more scientist groups in like reducing barriers for scientist groups in the global south so that they can participate more where a lot of science is being driven by the global north. This seems important. Scientists with disabilities who like can't necessarily read papers very as effectively or can't necessarily write as like can't churn out papers as fast as like able-bodied scientists, like including them also reduce the barrier. So there is this like, I guess like science of science work that's sort of motivated by that as a problem is driven by this view that like to push science forward, we want to enter a world state in which more of these people who are currently excluded from science or can't participate fully in science can participate fully on equal grounds with the people who are currently driving science. And that is that's the world state. And then there's like science of science work that maybe pokes at like possible causes, the possible directions that like hints at possible interventions that we might make towards that end. So science and science work could be just examining how inaccessible PDFs are. Like Lucy Wong's work on this is great.
I think it's been a pretty exciting discussion so far. I guess as primarily NLP researcher, I'm pretty excited about what kinds of opportunities exist at the intersection of NLP and science of science. Maybe say in the context of understanding scientific literature better, what do you think are the biggest exciting research directions in the intersection?
Like research directions in NLP?
NLP and yeah. How can NLP help with science of science?
How can NLP help with science of science? This is interesting. So there's obviously like a tool building component to NLP. NLP is just a very engineering heavy like the field itself is a solve this problem of like, we got all this data that we don't know how to do stuff with it, so we got to build the machines that can do stuff with it. That's literally NLP, right? Obviously you can use NLP to do like other scientific work like computational linguistics, et cetera, but like, NLP is a very like, we got to solve this problem kind of field.
Let me just say, I think a lot of NLP people will disagree with this statement.
Okay, sure.
I'm not gonna disagree with it, but I think a lot of people will.
That's my current hot take on it. So from this perspective, I guess what NLP could help with science of science is, if you want to do science of science nowadays, there's a couple of barriers that NLP could probably help resolve. One is just data access. A lot of interesting science and science work basically happens when you provide rich data. Think about like when Wikipedia, like how much NLP work, how much this work in general has happened off of Wikipedia, because it's accessible, it's available, it has all this rich hyperlink structure. People can just figure out all sorts of creative uses for it because it's available to researchers. Scientific literature, if you want to do large-scale scientific literature analysis around like how people communicate, how papers cite each other, who writes what papers, you just need access to that data. And right now, a lot of data is just like closed up under like closed source, like papers aren't necessarily open access, and they're not open access in like a IAD manner. That it's like this entire community gets their papers open, and this entire community, all of it is closed. So when you do science of science analysis, this is really, really tricky to actually do right, because if you do citation graph-based analysis and you have holes in your graph that are basically not because of IAD dropout, then what are the findings that you're making? You're saying, oh, these communities don't cite each other, but like, is that true, or is that just an artifact of you just literally didn't even have the data? And so it looks like
I have a solution for this. We just ignore everything that's not open access and just like exclude it from all the analysis, and that's like just make it irrelevant.
Just make it, but like that's the problem. I think the problem is like a lot of science of science, because science fundamentally is a lot of communication of ideas. It's hard to, you have to be able to account for things like references to each other, references between documents. A lot of science of science is based off this idea of a citation graph, so you can't just rip out a portion of the graph, drop all those edges, and be like, I'm gonna study this thing confidently without worrying about my findings. So I think NLP can basically help with maybe finding ways to build intermediate artifacts that support these kind of large scale analysis. So just like general data work, also just like cleaning PDFs and stuff like that, because if you try to work with PDFs before, it's like absolutely atrocious. So if you want to do basic things like grab all the contribution statements from every paper to see how people communicate contributions, I don't know how to do that at scale efficiently right now. And it feels like a really basic operation. So there's data. Also just tools for large scale sort of like information extraction, summarization tools can be useful. So a lot of science work involves this rapid iteration of like, you have a question, you look at the data, you implement something to look at some figures or some statistics, and then from there you go, okay, I want to check this other thing, I'll check this other thing out. So you want to shorten this like iterative loop between like a scientist thinking about some phenomenon and then seeing if that phenomenon exists in the data. And right now, that translating sort of that thought to code that works well is difficult, which is fundamentally a lot of this is like an NLP problem, and how to scale that efficiently, because you're analyzing millions of documents at a time, or a really big citation graph, and that's a efficient ML problem.
I want to unpack what you said, Kyle, because I think there's a lot. You mentioned multiple things here, and I want to comment on one thing. The NLP, like the ability to do NLP work on top of scientific literature, is something that has been extremely difficult a few years ago, and in big part due to the work that Semester team has been doing, it's become way easier. You guys, not to toot my own horn, but we did a shift in people's ability to process scientific literature at a mass scale, and now you have Scholar APIs. You can anyone who does NLP can just treat it as if it's any other data source, as if it's Wikipedia, if it's like reviews from or Quora questions, and that's really different than the situation back in 2016 or 2015. So kudos for leading a lot of these efforts, but also the last part that you mentioned, I didn't quite understand. Are you saying that, and so you mentioned also summarization, which is important. I know that you guys have done good work recently on summarizing, so generating shorter descriptions of scientific literature, which is something that's difficult to do because the genre is just like the complexity of the terms and all of this. It's just when you just use the summarization model out of the box, it doesn't give you good results. So kudos on that as well. I know your team did a lot of work here. The part that I didn't quite understand is translating this to code, and why is that necessary or useful?
So here's a concrete example that's been coming up. I had a previous project with an intern and Lausha around citation intent, trying to understand the intent behind like when a scientist one paper cites another paper. Why is that happening? Are they citing it as justification for something? Are they citing it to just give credit for like we use their model, we use their data, that it's et cetera, et cetera. The end goal was to do a large scientific study. We wanted to be able to say like, hey, maybe machine translation papers have this type of citation pattern. They all cite this few seminal works for their particular artifacts and be able to call that out. And then we can from there we can analyze that. Well, what makes these artifacts kind of special, where they're getting cited all often or not? This is a pretty easy question to articulate. Just like when I just asked, it's like, hey, yeah, I want to know what are the main data sets that everyone's citing. It's like, so I can conceive of that idea really easily. To actually execute on this, what do we have to do? Well, we need to be able to access all of these papers because that's where full text, because that's where citations are. So that's the data need. From there, we need to be able to classify these citational statements based on some fuzzy notion of like, what does it mean to cite a data set? Well, what is a data set? And what is citing a data set? Is it citing a data set because I used it, or is citing a data set because I'm comparing, like I'm interested in a new data set and I'm comparing against that one? We have those distinctions. And so figuring out this coding scheme requires running basically some state of model that can do this classification, or this building this taxonomy over citation context, looking at the results and going, oh wait, we should add a new category. Oh no, we should split this label into multiple things. And then rebuilding the model. And this loop is so slow. It's like data annotation work. You look at data annotation, then you build the model to do the thing, and then it's like you test the model. It's just, this is the classical NLP loop that is extremely slow right now, which is why this is where the value of a lot of these like large scale language models are coming in, is because they shorten that loop to get to some usable state. But even if you shorten the loop to get some usable state, let's say if I figure out the best prompt for GPT-4 on how to do this, now I need to run it at scale over like 50 million papers. And then I can't afford that. So that's the efficiency or scale problem of like, once I've gotten to a good state, I still need the results at a really large scale.
We also wanted to get a sense of the general community of science of science. What are the key venues where the research in science of science gets published? Are there like workshops, conferences that we should know of?
Yeah, the venues. Oh, there's so I guess like similar to my comment earlier, is like I think there's a lot of science of science work that's community specific. At least, for example, in the NLP space, there's a computational social science track at a lot of the NLP conferences. I think Tackle accepts computational social science or like community introspection works. So if you're an NLP person looking for science of science within NLP, there's works there. Broader, I think a lot of science and science work tries to go for these like big name journals. Like they show up in PNAS, they show up in Science, they show up in CACM. Sorry, like what is it? It's like I think they show up in like Science, Nature, a lot of these, but there's also just like a long tail of like journals that I don't necessarily read, but I've heard of. It's like the journals like sociology or computational sociology, etc. I think there's some science work that's necessarily, it's like more introspective about like how a scientist thinks through stuff, and that might show up in more like psychology journals too, but those can be very important works to think about as well. So it's sort of everywhere and diffuse, which is maybe a challenge.
Should we create our own conference?
I don't know. It's like, maybe I think there's merit in communicating results. So this is like, because I come from a statistics background, this is a similar thing. Like statistics, there's like a few core statistics journals, but a lot of them are more theoretical or like software based. And then a lot of statistics courses is actually embedded in the communities that for them. So like a lot of seminal statistics course happens in psychology or happens in like geospatial, like environmental sciences. And it's because after you get away from like really big abstract general methodology and you start tailoring to a particular community, well, you want that community to adopt it. And so you kind of embed your work into that community. So I think there's also merit in like science of science work once it goes one layer more specific to be close to the community that they're studying.
How about let me do a counter proposal? We can have a venue where it's exclusively republishing work that's focused on sci. Like we're not soliciting new contributions. We're soliciting people to resubmit the things that they already published or pre-published on arXiv. This way, we have like one concentrated venue where everyone who cares about sci can come and kind of like like learn and be exposed to the areas that are like the sub areas in sci that they're not particularly working on.
Yeah, I mean, there are like conferences for science. I think there's literally just like the International Conference of Science, etc. I mean, sure. I mean, like, like more. I actually really like the idea of like decoupling submissions, like for publication and like conference activity. I know a lot of fields kind of do this. So sure, idea of like republishing or like submitting an abstract is like, here's this body of work, you're presenting 3 papers or even 1 paper, etc. And trying to pull people from across different pockets into one venue seems fun.
Really, what's happening here is I'm trying to get you to say yes because I've been wanting to.
You've been wanting to organize. I feel like something exists already, and it's just like my fault for not attending it or like not knowing about it. I think really the difficulty here is just like getting away from. There's very strong incentives to attend your own particular community, and so science of science is fundamentally an interdisciplinary field, right? It combines a lot of data science stuff with NLP stuff, with psychology stuff, with sort of like philosophical stuff. It's like getting people. I think it's going to be the same barrier as just like why there aren't as many interdisciplinary researchers as we would all like there to be.
Yeah, given the more recent advances in, I guess, AI in general, and also maybe particularly NLP, and also the availability of lots of different kinds of data, my guess is that the community of science of science would be expanding more, would have expanded more in the last few years. Do you think that's true?
Maybe I could buy that. It's like access to data, access to compute, anything that like access to sort of like powerful machines that like fundamentally lowers the barrier to be able to do large scale data analysis. Like if you can prompt your way to classifying text and stuff, and you can do a little bit of Python notebooking, you could do science of science work at this point, right? Compared to maybe 10 years ago, then you had to actually build your own model for certain things, et cetera, et cetera. So fundamentally, as like tech becomes easier, more accessible, and then data becomes more accessible, I can see that lower barriers means more people participating. But again, like I don't know where it's all happening.
All right. So the last question I have for you is: you have a new intern or a new researcher joining the group, and they are, they could work on LLM research or they could work on sci work. Which one do you think more people are excited about within the demographic of people like you have onboarded in the team so far? And I'm using this as a sense of to what extent is it a hot topic? Because LLMs, of course, is extremely hot.
I think
on average, more people want to do the LLM based work. When I recruit mostly from my own publishing community. This is like for people who I know, and that would be like sort of the machine learning crowd as well as the NLP crowd, and that tends to be the thing that like everyone wants to work on. It's like I want to touch the LLM and do stuff with it or do stuff to build them. Science of science. There's definitely people in science and science in these particular communities, but again, they're just like fewer because of the nature of it being interdisciplinary, and it's sort of like this like meta commentary type of work over a field. There's going to be fewer people who want to do that. So
yeah, do you want to plug to do a quick plugin for Olmo because I know you've been leading the science data component of it.
Data component, yeah, sure. If so, Luca Soldani and I are co-leading the Dolma project, or I guess just like data pre-training data for Olmo, our large open language modeling project. It's not like we're not necessarily building like a model and this is the model to like combat the proprietary models, but more of a well, we want our publishing communities, our academic communities, to have healthy access to data, models, code, etc., so that we can keep studying these artifacts, especially in light of a lot of these things are going close, sort of going dark. So I don't want my career to be prompting XYZ API and just like trying to form theories around what might be happening with these models. I actually want to study what's going on with these models. So the Olmo project hopefully is about releasing artifacts that will support our ability to do research on this, as well as just our own academic communities that we care about, so that everyone can also do research on these in a sustained, healthy manner long term. And part of this is modeling work, but part of this is also data work, so that people can scrutinize the data. We can verify things like how much hallucination is actually happening, how much memorization is actually happening. It's hard to know unless you know the data and have the model that you trained the data, like with the data that was trained on. So
why is this better than, like, why would I use this instead of Llama if I'm interested in specifically scientific documents?
So for Llama, if you're trying to basically like process scientific documents to some sort of end, you might actually want Llama. One, because there is no Olmo model yet. So like if you're gonna just work on something now, use Llama. It's great. It's like if you're trying to study, if it's not getting enough performance and you want high performance for a particular medical information extraction task, or like a scientific information extraction task, or something task, you might want to look at our data, because we have quite a bit of scientific literature that we've been able to identify as open access, cleaned up, processed, and released publicly as part of this Dolma project. The collection is called Pesto, which is sort of like our Stork scientific paper collection, cleaned up and processed, removing a lot of stuff to make it more conducive for language model training. And it looks like a lot of people are using this collection right now to do continued pre-training. So if you want to do Llama, continue pre-training, or Minstrel, continue pre-training. Just check out our stuff. But it's like, use whatever you want to use or don't use it. It's just like, we're just like releasing stuff that hopefully is useful.
You're so not a salesperson, Kyle.
I know. I don't like selling things. No, I think the data is good. I think data is good. Check it out. If there's any problems with it, like let us know. We'll fix it.
No, great, awesome. So, but just to rehash some of these things. What is Stork? Could you help the reader or the audience understand what is Stork?
Yeah. So Stork is a large collection of full text scientific articles that we've identified as open access, so we feel safe to release them in their machine readable form. But the key thing is that we took care of all of the nonsense that has to come with dealing with PDF parsing and figuring out structure in the document, like what is the abstract, what is the body text, what are the sections, what is the bibliography, etc., as well as like where's the citation, what does the citation actually point to, etc. These types of things that are repeatable asks for people who want to study scientific articles. it's really annoying for every new project to have to go through this yourself. So what we did with Stork was we basically just did it all once and then made it a service so people can access it. So there's just like giant dumps of these articles now.
And it's a very valuable service. And how about Dolma? Is Dolma considered a subset of that, or is it a completely different project?
Yeah, Dolma is specifically around language modeling. So it's a superset of this, I would say, or actually it's more like there are different needs. So with Stork, let's say, we want to support general scientific article research. So if you want to do a citation graph based project, you could use Stork to get citation context because we have citation mentions in the articles resolved to their cited papers. So we have citation edges. But for language modeling, a lot of language modeling doesn't actually require a lot of the structure. At least you just kind of just need plain text documents linearized into one humongous string and then cleaned up in certain ways. So we took Stork and we cleaned it up for language modeling specifically. And so that includes removing large swaths of the text, which might be valuable for certain types of research, but maybe not as valuable for language modeling. And then this became Pesto, which is the science component of the larger pre-training corpus called DOMA. DOMA contains other stuff like web crawl data from Common Crawl, Gutenberg books, Wikipedia, other pre-training corpora like C4, etc.
Awesome. Thank you for explaining this. And then there's Spectre is, I'm just like helping you kind of like tell the audience
dear.
all the gadgets that you guys have built recently.
Gadgets and stuff.
Do you want to tell us about Spectre? Because Spectre is quite closely related to this, but it's, like it kind of like addresses a different audience.
Yeah. Spectre is our embedding, I guess like paper embedding type of work. So it was originally born, I think Armand Kohan led the work with you and several others. And the idea is that there's a repeatable operation in a lot of scientific NLP work, which is you want to find nearest neighbors between documents. You want to be able to say, this document, oh, I want to give me all the documents that are kind of like it, maybe in terms of field of study, in terms of topic or focus. But I want to be able to just grab a pool of documents and find nearest neighbors. And the best way we know how to do this is by taking the document, embedding it into some vector, and then putting all the documents in vector space and you doing nearest neighbor in vector space. So how do you embed the documents? Spectre was a technique back then to embed documents, and using basically citation graph signals. So if a paper cites each other, that's a positive link. They're probably related, so they should embed it together. If they don't cite each other, it's a negative link. They probably don't. There's no link, so they're more of a negative pair. And you can think of all sorts of training techniques for this. Spectre 2 was released recently, or at least it'll be at EMNLP. And I think that's the project that tries to embed a whole bunch of other stuff as well, like authors, venues, etc. So just treating like not just papers, but also as the nodes, but also just like these other heterogeneous entities that exist in a citation or academic graph.
Yeah, if anyone is working on scientific documents, as far as I can tell, this is the best model for inputting the scientific literature. So check it out. And anything else that you wanted to kind of like highlight of the work that you guys have been working on recently?
Yeah, I guess there's a couple of stuff that I guess there's like one thing that we're presenting at EMNLP that I think might be a useful tool for people. We're releasing, actually, we presented this at WIST, and then we're also presenting at EMNLP. But we have a lot of reusable software now that we use in-house for processing scientific papers and then like building UIs, like reading interfaces over those scientific papers. So, and a lot of that code is now open source, so you can feel free to grab it. PaperMage is one of our Python libraries. It's basically just like a pip installable tool where we pull in a whole bunch of computer vision techniques and NLP techniques and just dirty code heuristic rules to basically convert any arbitrary PDF into some structured representation. And the key thing about the structured representation is it's not just oh, this string in this document is the title or the abstract or whatever, but you also have the XY position of all of these entities on the page. So if you want to do multimodal analysis, you could do it with this library. The key thing that we basically resolve here is a lot of this really annoying boilerplate code that nobody wants to write. Like if you have an NLP text-only technique, let's say if you extract all the entities on a page using some Hugging Face model, that's text only, and now you want some intuitively like, well, I want to highlight it on the page, like just put a blue box on it. Where do you get the bounding boxes from? Like this library basically takes care of a lot of that. So more just like making life easier type of stuff. And then similarly, a lot of our HCI researchers have built this UI toolkit, basically a React components library. So if you want to build a reading interface that can surface a whole bunch of like any sort of NLP that you do on top of a paper, if you want to visualize it and you don't want to build the UI, a lot of that code is already public. And this is the same code that we're using for the production semantic reader. So if you want to build something similar, go ahead and take all of it. That UI is called Papercraft. The backend is called PaperMage. I think it's all already on the internet.
Sweet. Yeah, that sounds super useful for anyone building products on top of scientific literature. So thank you for sharing that. Just you mentioned something, you said any PDF, but my impression is that you only work with scientific documents. Is that right?
Yes, sorry, any scientific article PDF. You can technically run any PDF at it. I don't know what happens at the end of it. Like it could just be chaos.
It would be fun to see how it does on legal documents, because legal documents share a lot of kind of like these elemental pieces with the scientific literature.
I think so too. Yeah, I think so too. I think that the legal document thing, they're a lot less problematic when we tried it out. So we had this project with like the clearinghouse.org with trying to parse like sort of civil rights lawsuits, and there's a lot, at least from those, it's like the problems here are like big tables, which everyone has troubles actually parsing. But there's a lot less like 2-column format, very dense figures. Like scientific articles are just like horrific at like trying to compress as much information onto like a few pages. Legal documents, I think, are more liberal with like, oh yeah, we can have this thing run like a few hundred pages long. So the parsing is
the idea of having 2 columns. Who came up with this idea? That's such a bad idea.
I don't know. It's like atrocious to try to deal with, but yeah, I guess so. Those are some tools that maybe people would find helpful. And then I guess beyond that, I don't know. I guess like recently generally thinking about like what's important to build and what's not important to build, or like what's like a bad idea to build. For I guess like accelerating science.
Okay, with that note, thank you so much, Kyle, for joining us today. Really appreciate all the insights you have into this field and sharing it with the audience. And I apologize for this noise. It's just the perfect time for the person who's cleaning the.
I actually can't hear it. I think the noise cancellation is really good on.
Perfect. Technology works sometimes.
Cool.
Okay, see you, Kyle. Bye.
Cool. See you, Waleed. Bye.